Okay, welcome to Shabita Uganda e-learning. My name is Nelson, and in today's video we are going to make a continuation and looking at the questions that are always asked when it comes to representation of prime factors on Venn diagram. So we shall go straight to those questions. We shall go straight to the questions. So these are our questions. Yesterday in our recent video we are able to look at our question 1. Okay, so in this video we shall be able to look at our question 3 because our question 2 also have the same workings like those of question 1. Okay, so when you look at our question 1, we said represent the prime factors of 4 and 8 on a Venn diagram. Okay, and then our question part B of it says find the lowest common multiple of 4 and 8. Okay, on the above diagram. So we are able to discuss this in our recent lesson, and we said that for us to be able to answer such a question, first of all we need to be able to list out the prime factors of 4 and 8. Then after we can be able to present it on a Venn diagram. So this was our recent lesson that we did. Please, if you never attended this, be part of it. First be able to first listen or first watch our lesson for you to go with us on the same pace. Okay, so our today's main purpose is to handle question 3 because we are saying question 2 has the same question 2 has the same knowledge. They are saying show the prime factors of 10, 20, then the GCF and the LCM. Okay, so we shall automatically go to our question 3. So our question 3 is saying when you look at our question 3, they have given us the already set. They have presented us a set on the Venn diagram. Okay, so after presenting it on the Venn diagram, then they tell us to find out the lowest common multiple of 16 and 12. Remember, we are able to see how do we represent this and what each one means. So these are the prime factors of 16. Prime factors of 16 are passing from here up to here. Then prime factors of 12 are passing from here up to here. So this uses our basic concept of sets that we are also able to look at in our recent videos. So we shall use that basic concept of sets for us to be able to understand and to solve out these numbers of ours. Okay, so let me draw here something where we can discuss from. So here what they want us to find our part A. They want us to find the lowest common multiple. That is using prime factorization. As you can see, this as it is represented on the Venn diagram, it is a working of the prime factorization method. Okay, now using either ladder method or using factor tree method. Okay, so now how do we get the LCM of 16 and 12 using this Venn diagram? Now, for us to be able to get the LCM using the Venn diagram, our LCM here is going to be equal to the prime factors of 16 union the prime factors of 12. Okay, That's what we shall be able to do. For us to get the lowest common multiple, we use a formula. The prime factors of 16, which is this one, then union the prime factors of what? Prime factors of 12. So we said a union of a set simply mean when we get all the members within the set without repeating each represented. So now here that's simply mean if you are to get the union of this set, the union of this set shall be equal to, our union of this set shall be equal to, let's list them one by one, and accordingly we are going to start with 2 1, 2 2, 2 3, then 2 4, then 3 1. Why? Because we are just using a format of becoming or ascending just in an order. So we are going to say 2 1, going to say 2 2, going to say 2 3. Okay, then 2 4. Okay, then 3 what? 3 1. Okay. So that is how we are going to represent, and these are our what? Our values. Okay, I know there is someone asking me how the 2 1 comes about, the 2 2 comes about. Okay, this comes from getting the prime what? Getting the prime what? The prime factors. Okay, so let's have a look of an overview how we get these numbers. So how do these come about? The 2 1 and the 2 2, the 2 3. Okay. So how does that one comes about? This is by using our prime factorization. Let's say we have our 16. If we use our method here, we are going to use our factor tree method. We are going to use our factor tree method. Okay. Let's do it from here. When we use our factor tree method, we have our 16. Okay, so in our 16, we shall look out for a lowest number that can divide the 16. We are going to try our 2. Okay, so when you divide the 16 divided by 2, we get our answer as what? 8. Okay, so we have now our 8, which is the answer. Then we also divide our 8 by 2. What do we get? Our answer is 4. Okay. Then we also divide our 4 by 2. Here we get our what? Our 2. Then we also divide our 2 by 2. 2 divided by 2, what do we get? We get our answer as 1. So this simply means that when we divide our 16, all this one becomes our prime what? Our prime factors. Okay. Then we look at how many times does our prime factors appear. We have a 2 appearing for the first time, a 2 appearing for the second time. Okay, then a 2 appearing for the third time. Then we also still have our 2 here appearing for the what? For the fourth time. Okay, so now this clearly shows us that 2 3, 2 4, 2 1, 2 2. Then also we have what we call a 3 here. Okay, a 3 here. Using the same method, that's how we can also get the prime what? The prime factors of 12. Okay, so in 12 we have when we divide 12 by 2. Okay, when we divide 12 by 2, our answer is what? We get our answer as 6. Okay, so also here when we divide our 6 by 2, we shall be able to get our 3. Then also we have our 3, but we can't divide the 3 by 2, okay? So we look out for the lowest number that can divide the 3 and we get no remainder. We have our 3. So when you say 3 divided by 3, we get our answers what? We get our answers 1. So this simply means that also here we have a 2 appearing for the first time. We have a 2 appearing for the second time. Then we have our 3 appearing for the first time. Then we said that for us to be able to know the intersection and the union, then this simply means we can now arrange our 2 1, okay, our 2 2, our 2 3, then our 2 4, okay. Here we have commas. So we can see that this is a set of prime factors that we have been able to get. So this is now in a form of a set a set notation. So also for the prime factors of 12, we can also be able to write them and say we have our 2 our 2 1, we have our 2 2, then we have our 3 1. So this is also the prime factors of prime factors of 12, okay. Prime factors of 12, then prime factors of of 16. So now this shows us how they were able to come up with this set. Now what to do is to represent it on the on the Venn diagram as it is there, okay. So now this was just a quick overview of how they were able to get these prime factors that are inside our set our set notation. Okay, so now let's look at how do we find the LCM. We said for us to be able to find the LCM, we need to our LCM here is going to be equal to our prime factors of prime factors of 16, then union the prime factors of the prime factors of 12, okay. So now here we can even be able now to list the prime factors of 16 union union 12. Okay, so here now we can arrange them. We can arrange them very well. Let's arrange them. We have our 2 here, and our 2 here, our 3 here, our 2 here appearing for that. Then we also have this, then we also have this, then we also have this. So what do we do here? We arrange them, but if we have our 2 1 appearing here, that simply means we shall write it once, as we have been using the same concept of sets when we are looking at union of sets, okay. So here now we have our 2 1, here now we have our 2 2, we have our 2 3, we have our 2 4, okay. Also here a continuation, we have our 3 1, okay. So this is going to, okay, so now this represents our it represents our union of of sets. So now after identifying and listing out our union of sets, then we continue and say that our LCM is going to be equal to now the multiplication of our prime factors, because this simply means the lowest common multiple, okay. After it comes from multiplication, multiple from from multiplication. So now here we shall be having our 2 times 2 times 2 times times 2, how many times, times times 2, then times times our 3, okay. So this is going to be our LCM, where this is going to be our 4 times 4. Okay, our 4 times 4. This is 2 times 2, we get 4. 2 times 2, we get 4. Then times what? Times 3. Okay, so when we say 4 times 4, we get 16 times 3. Then we should be able to come up with our what? With our answer. What is 16 times 3? This is the same as 3 times 6, which is 18. Okay, which is 18. We write 8, carry 1. And we say what is 3 times 1, we get 3 plus 1, we carry it becomes 48. Okay, so now this becomes our lowest common multiple using what? Using prime factorization. So our other question was looking at the greatest, okay, the greatest common what? Common factor. Okay, so for us to get the greatest common factor, as they are saying here, find the greatest common factor of 16 and 12. Okay, 16 and 12. Greatest common factor of 16. Okay, let's write of 16. 16 and 12. For us to be able to get our greatest common factor, we shall be able to say, we use this formula which says f of 16, the prime factors of 16 intersection the prime factors of what? Prime factors of 12. Okay, so now let's look at these prime factors of 12. From here we can even be able to identify them. Okay, so those that are common, we have our 2 here. This one is common. 2 also is common here. This one is also common. It is here and it is also here. It is also what? It is also here. So this appears this side and also appears that side. So it makes it to be what? To be intersection. So now this simply means that here we shall now be able to get our f. This is going to be equal to our intersection, which is what? Which is 2, 1, then 2, 2. For those appears what? They appears in both of them. To refer back to the question, we are having this is the one that we are getting 2, which is in the what? Which is in the intersection. Okay, so now let's now look at how do we find the greatest common factor using prime factorization. So here we shall now be having our 2 times 2. Then we should be able to come up with our 4, which is going to be our what? Which is going to be our answer. Okay, so for this we shall now have solved our number very well, and we shall have been able to solve the lowest common multiple using prime factorization, also the greatest common factor using what? Prime factorization, extracting the information from the what? From the Venn diagram. Hope everyone has been able to pick out something, and hope we are moving at the same what? At the same pace. So that's how we shall be handling these numbers. So our next lesson we are going to also answer this number of hours as it is given here, f of x, then f of y, then there we shall also be able to see how do we find that. Okay, so for this let me say thank you very much. Thank you very much for being part of this lesson, and please be able to subscribe in order to get some more upcoming lessons for all the subjects. And also please put our comment on the comment section for us to know exactly where we can move with you on the same page. Okay, God bless you. See you in the next lesson.